So trigonometry, it's really kind of like the art or the math of relating the sides of a triangle. Mainly it's with a right triangle, but we always start with right triangle trig, which is just the basic SOHCAHTOA stuff. But it's combining, it's making that relationship between the angles and the side lengths. Hi, I'm Sarah. I've been a STEM teacher for 20 years, and I like to make math engaging and fun and not so scary for everyone involved. Follow me on all the social media platforms and check out my Patreon if you're interested in some tutoring, some Patreon-only live streams. Check it out and click the link and do the stuff. We know if you've been working with right triangles, right? You've got to make sure that the side lengths are in a certain proportion, right? Or a certain ratio, right? And they fit the Pythagorean theorem. So like a squared plus b squared equals c squared. So you know that those legs, right? Those legs have to be certain lengths. So not only do you have like limits on how long the legs of a triangle can be, right? You can't just have any 3 legs. You can't have like 3, 5, and 23, right? The 3 and the 5, they wouldn't reach out to the sides of the 23. So to be a right triangle, you can't just pick 3 random sides because they have to fall into place. Now, with these right triangles, the side length, or with any triangle really, the side length is determined by the angle. Okay, it's determined by the angle across from it. So if this angle were a little bit bigger, this side length would be longer, right? Nothing's going to change about this. Like if this is a right triangle, that angle opening up and or closing, right, is just going to make this side longer, okay? Like that, okay? So if you just know the angle and one side, now everybody learns with Pythagorean theorem, everybody learns that, if you've got 2 legs of the triangle, you can figure out the third one, right? You can plug it into Pythagorean theorem and then solve for the leg that you don't have, or for the hypotenuse or the leg or whatever. But what trig does is it's almost like it takes it a step further to where it says, okay, not only do these legs all have to be in these specific proportions, but to make those legs in that specific proportion, it's got to have this particular angle. So each angle also determines that same ratio between the legs and the hypotenuse. Okay, so for example, so when we have these ratios, so if we are talking about, we're bringing in an angle measurement, right? We call that angle theta. It's like a 0 with a little slash through it. Okay, so that's theta. So then if this angle is theta, and this angle can be theta or this one can be theta, it doesn't really matter. Whatever this angle is, this theta angle is, it's going to determine these particular side lengths, okay? Because again, because a right triangle has to fit in with Pythagorean theorem, because the right triangle has that sort of like boundary on it, the angles are also kind of tied in with that, okay? So when you've got something, so when you've got theta here, we call this side the opposite. This one is the hypotenuse. Right? Probably nothing new, but that's the hypotenuse. And this one is called the adjacent because it is right by the theta. Okay, now if theta were up here, this would be the adjacent and this would be the opposite. Okay, so this is always the hypotenuse. Hypotenuse is always across from the 90-degree angle. So the trig ratios are just that. They're ratios of the side lengths based on what the angle is, okay? So sine of theta looks like sin, but it's sine. So sine of theta, whatever that theta is, sine is the ratio between the opposite over the hypotenuse, always. So if you have a particular angle, it's going to be that relationship, and it's always going to be the same, okay? No matter how big the triangle is, no matter how small the triangle is, that ratio is going to remain the same, okay? So for example, sine of 30, okay? Sine of 30 degrees equals 1/2. Always. It doesn't matter, okay? It doesn't matter what the side lengths are. What it means is that the hypotenuse is always going to be twice as long as the opposite. If that is a 30-degree angle, that's going to be half the length of that. Always. That's it. Okay. So sine is the opposite over the hypotenuse. So that's the SO, right? You hear SOHCAHTOA. Okay. So is SOH. Cosine. So cosine theta is the ratio. So ca is adjacent over hypotenuse. And then tangent is the TOA. So tangent is opposite over adjacent. Okay, so that's what that is. So we've got SOHCAHTOA. So remember, it's just a ratio. It's just that relationship between those signs, right? Between those sides. That's mathed up.